You, yes you, you're listening to and watching review recording 1A and B to accompany instructional recordings 1A and 1B for Section 8.2 of Unit 8, Chapter 8, Mathematics 2200. We'll do a couple of examples related to solving systems of equations algebraically. Example 1. We're asked to solve y equals x minus 3 and negative x squared plus y plus 3 equals 0. When doing these, try to pick the most efficient method. If I try to do elimination here, I can do it. The only issue with it is I've got some rearranging to do. Whereas if I do substitution, I've already got y isolated here, so I can put the x minus 3 that I have right here in place of the y right away. Therefore, the second equation right away becomes negative x squared plus x minus 3 plus that 3 that was already out there equals 0. Fixing my bracket there, I now have negative x squared plus x minus 3 plus 3. Those 3's will cancel. And I've got a quadratic. I can take out the common factor of negative x outside of x minus 1 equals 0, making each factor equal 0. I have x equals 0 or x equals 1. I go back to my linear equation because it's easier. I substitute in y equals x minus 3, and I've got y equals 0 minus 3, which is negative 3. So I've got a point of intersection at 0, negative 3. And if I put the 1 in, I will have a point of intersection at 1, negative 2. So A is my correct answer. Example 2 has 5x squared plus 4x minus 2y plus 1 equals 0, and x squared plus 3/4 x equals 1/2 y minus 1/4. Now, we use a skill that we learned in the chapter on rational expressions. If we multiply the second equation by 4, the LCD, let's see what happens. I'll get 4x squared. 3/4 of 4 is just 3, so I've got 3x, equals 1/2 of 4 would be 2y, and 1/4 of 4 would be 1. So I'm going to have minus 1 there because it's a negative times a positive. If I'm going to use substitution, I'm going to have to divide everything here by 2 to get y by itself. I'd have to do the same thing up here, so I'll wind up with the fractions again. Substitute, or elimination rather, is probably the better way to go. I'll want to align like terms, however, so I think I'll rearrange this equation to be in the same form as the other one. So we've got 4x squared plus 3x minus 2y plus 1 equals 0. Now I take another look at those two equations. I've got all my terms lined up. I want to add these up so that the y's will eliminate. That won't happen yet. So I multiply one of these equations by negative 1. I'll choose to do the first one. By negative 1, I get negative 5x squared minus 4x plus 2y minus 1 equals 0. The second equation I can just leave alone, or just multiply by 1, if you like that. So I've got 4x squared there, plus 3x minus 2y plus 1 equals 0. I now add those two equations. Negative 5x squared plus 4x squared is going to be negative x squared. Negative 4x plus 3x is negative x. My y's are now gone. My negative 1 plus 1, they're gone as well. So I'm left with negative x squared minus x equals 0. I solved that resulting equation. So I've got negative x outside of x plus 1 equals 0 when I factor. Make each factor equal 0. And I've got my two roots, or my two solutions for x equals 0 or x equals -1. Now it's clearly a lot easier to go back to equation 1 to determine our y values. So I'll put in x equals 0 there. 5 times 0 squared plus 4 times 0 minus 2y plus 1 equals 0. Let's move that middle line over a little bit. There we go. And that gives us minus 2y plus 1 equals 0. Switching that around, I get negative 2y equals -1, so y equals positive 1/2. Now when I do the -1 in the same equation, I get -1 squared there, times 5 would be 5, plus 4 times -1 is -4. So I get 5 minus 4 so far, which is 1, minus 2y plus 1 equals 0. So I've got 5 minus 4, that's 1 plus 1, and I got -2y plus 2 equals 0. So it gives me -2y equals -2, y will equal positive 1. So I'll have points of intersection at 0, 1/2 and at -1, 1. I checked my work, I put 0, 1/2 into the first equation, and it indeed balances it. Now I have to check it in the second equation. And indeed, 0 squared plus 3/4 times 0, that's going to give me 0. Over here on the right-hand side, I'll have 1/4. A half times a half is a fourth. And so I've got 0 equals 0. I leave the check of the point -1, 1 for you. To solve a system of equations algebraically, try to select the more efficient method, substitution or elimination. Make sure you write solutions as points of intersection and check your points in both original equations.